Hello and welcome to Nick's Algebraics. So today and the next couple of videos I'm going to make are going to be about preparing you for Algebra 1. So today's topic is the sets of numbers. So one set of numbers that you're very familiar with and you've known ever since you started counting are the positive numbers. So these are the numbers greater than 0. So on the number line, they belong on the right of 0. And later in your education, you learn about negative numbers. So negative numbers are the opposite. They are the numbers less than 0. So on the number line, they're to the left of 0. And you might be wondering, what about 0? Well, 0 is neither positive nor negative. It's just 0. It's nothing. And also, even later, you learn about square roots. So square roots are one of two equal factors of a number. So let's take 36 as an example. 36 has many factors. There's 1 in 36, there's 2 in 18, there's 4 in 9, but we're looking at the equal factors. So the equal factors would be 6 and 6, because 6 is equal to 6. So that means when you take the square root of 36, that's going to equal 6, because 6 squared is 36. So this is known as the principal square root. It's the non-negative square root, so it's the positive square root. So there's also a negative square root, because someone could also say, oh, the square root of, when you take the square root of 36, it could also equal negative 6, because negative 6 squared is also 36. So now I'm going to talk about other different sets of numbers. So one specific set of numbers are the natural numbers. So the symbol for this is an n, like that. And these are the numbers that exist in nature. And they're also known as the counting numbers. So they're numbers like 1, 2, 3, and so on. By the end of this lesson, you'll be a natural at this. So something a little more general are the whole numbers. The symbol for this is a W. So all natural numbers are whole numbers. So that's why I put natural numbers inside of whole numbers. So it includes 1, 2, 3, and so on, but it also includes 0. So that's the only difference. It's also a whole lot of fun. So beyond that are the integers. So you might be wondering, oh, the symbol for that's definitely I. But no, we're going to keep that I for later. So it's actually a Z. The reason why it's a Z is because the Z is a German word, Zahl, and it's just German for number. So the integers include the whole and natural numbers. So it includes 0, 1, 2, 3, but it also includes negative numbers. So -1, -2, -3, and so on. So even more beyond that are the rational numbers. So in the word rational, you see ratio in there. So ratio is a comparison of two numbers by division. So it takes the form of a over b. So it's basically a ratio between two integers, where b does not equal 0, because you can't divide by 0. So the symbol for this is also kind of weird, because we're going to save the r for later. So this one is a q. The reason why is because when you're dividing something, the result is the quotient. So that's where you get the q from. So these include everything we just talked about, but it also includes fractions because it takes the form of a over b. So that includes like 5.3 or -1/3 or 0.5. So rational numbers can repeat. So you might be wondering, but what if I can't put into a fraction? What would that be called? So 1, that's a great question. And 2, those would be called irrational numbers. So it has ratio in it. You can't put it into a ratio. So these do not have a pattern to it. Like one famous example is pi. That equals 3.14159 and so on. It just keeps on going on. It doesn't repeat. It's just pretty random. And it doesn't terminate. It doesn't stop. So another example would be like root 2 or root 3. So let's go back to square roots. Let's talk about perfect squares. So perfect square is when you take the square root of a number and you get a rational number. So like we said earlier, square root of 36, you get 6. That's a rational number. So therefore 36 is a perfect square. Square root of 2.25, that equals 1.5. That's a rational number. So 2.25 is a perfect square. So when you take the square root of a number that are not perfect squares, then you get irrational numbers. Also, the symbol for irrational is going to be the I. It's not for integer, it's for irrational. So all these sets of numbers are called the real numbers. And that's what we saved the R for. That's the symbol for real numbers. So these are all the numbers on the number line. So the fun involved with these numbers are also very real. So let's do some examples. Let's name the set or sets of numbers this number belongs to. So this is not a natural number because it's not a counting number. It's not like 1, 2, 3, 4, 5. So we could cross that out. It's not a whole number because whole numbers are just natural numbers and 0. It's not an integer because integers don't include fractions. But it is a rational number because rational numbers include fractions. It includes ratio between two integers. So this number, if you put it into your calculator, it equals 0.227 repeating. So there's a pattern to it, and I could put it back into a fraction. So I can't do that with irrational numbers, so it's not an irrational number. But it is a real number as well, because it's on the number line. Another example would be the square root of 81. So the factors of 81 would be 1 and 81, or 3 and 27. But there's also 9 and 9. So those are the equal factors. The square root of 81 is 9, because 9 squared is 81. So 9, that's a counting number. That's a natural number. And that also makes it a whole number, because whole numbers are just 0 and natural. And that is also an integer. It's also a rational number. It's not irrational because it terminates, it stops, and it's a real number. What about the square root of 56? So some factors of the square root of 56 are 1 and 56, there's 7 and 8, there's 2 and 28, but I can't think of any two whole numbers that are the same that multiply to 56. So let's put this into our calculator. So if you do, you get 7.48331477 and so on. So 56 is not a perfect square. So if I take the square root of it, it's going to be irrational. So that means it's not rational, it's not natural, not whole, not an integer, but it's also real because it's on the number line. The square root of 56 does not terminate, and it also does not repeat. The numbers are pretty random. So what does it mean to graph something? So when you graph a set of numbers, that means you're going to draw or plot the points named by those numbers on a number line. And the number that corresponds to a point on a number line is called the coordinate of that point. So we have a set of numbers, and let's graph them on a number line, and let's order them from least to greatest. So 6 and 4/5. If you put that into a calculator, that equals about 6.8. And the square root of 49, that's a perfect square, so it's 7, because 7 times 7 is 49. And 6.3 repeating is just 6.3333 forever. And the square root of 57, if you put that into your calculator, is 7.546, and so on. So that's an irrational number. It's not a perfect square. So it looks like all the numbers are between 6 and 8. So we're going to have 0 over here, and 6, and 8. And we're going to put 7 in the middle. So let's start with 6.8. So 6.8 is a little under 7, so I'm going to put it right here. So that's where the 6 and 4/5 goes. 7 just goes right on 7. 6.3333 is just under 6.5, 6.5, so it's going to go right here. 6.3. And root 57, which is a little over 7.5, is going to go right there, a little above the middle of 7 and 8. So now when we list them from order, we're going to go from left to right. So the smallest number here is 6.3 repeating, then it's 6 and 4/5, then it's root 49, then it's root 57. Let's do another example. So root 20, if you put that into a calculator, that equals about 4.4721 and so on. 4.7 is 4.7, we know that. 12 over 3 is 4, 12 divided by 3 is just 4. And 4 and 1/3, well, 1/3 is 0.3 repeating, so it's just 4.33333. So all these numbers are between 3 and 5. So we have 0 here, 3, and 5. And we'll put 4 in the middle. And by the way, this is not drawn to scale. So let's start with root 20, which is 4.47. So that's going to be a little under 4.5. So it's going to be a little under the middle of 4 and 5. So like right there. 4.7 is going to be a little above 4.5. So it's going to be closer to 5. It's going to be around right there. 4.7. 12 over 3, which is 4, just goes straight on 4. And 4 1/3 is a third away from 4. So it's going to be around right there. That's going to be the 4 1/3. So if we put this in order, we have to go from left to right. So the one farthest to the left is 4. Well, 12 over 3. Then it's 4 1/3. Then root 20. Then 4.7. And that's it for today's video. Don't forget to subscribe, like this video, and turn on your notifications. I posted some worksheets below with the answer key attached to it, and I'll see you in about a week.